Hi everyone, this is Rahul Chaturvedi and you are watching Telecom Notes, and today we are discussing about the LTE architecture with the frame structure. So let's start with the LTE architecture. Coming to the first slide, EPS Network Architecture. As you can see, with the dotted line is the control plane and the straight line, the continuous one, is the user plane. So starting from LTE, LTE is your device having the SIM card in it. LTE is the interface between the E node B. E node B is the first unit that has been just introduced in the case of LTE architecture. After that, it's the core part, but between the LTE and your E node B, there is LTE interface, that is the air interface, and as we can see, E node B is connected to another E node B with the X2 interface that helps in admission control as well as in case of the handover, X2 base handover, and also for the load sharing, E node B to E node B are just connected. While in the previous technologies we are having RNC to RNC connected, not with the BTS ones. So LTE is connected to E node B, and this particular interface is having the control plane also as well as the user plane. After that, the control plane and user plane has been just separated out. The interface between the E node B for the control plane further as well as for the data path is the S1, and it's divided into S1 MME and S1 U. S1 MME is the interface between E node B and MME. MME is mobility management entity. While in case of S1 user plane, S1 U, it's between the E node B and S gateway, the serving gateway. As you can see, the S10 is connected within the MME itself. That means that MME is connected to another MME also by using the S10 interface. Now coming to the HSS, home subscriber server, is connected with the MME using the interface S6A. Furthermore, coming to the data path now. So S gateway is connected with the data path having the S5 and S8. S5 is for the not roaming, and S5 is used, S8 is used for the roaming purpose. Before that, let us just connect, because in this we can see the dotted path also. To explain that one, I have just connected MME with the S gateway using the S11 interface. It do not handles a particular S gateway, but indirectly it accesses the P gateway to take out the particular IP from the PDN. So indirectly MME is connected to P gateway through S11 and S5/S8, that is control as well as the user plane, and P gateway is connected with the PCRF, policy and charging rule functionality, by using the control plane itself having the interface S7, and SGI is directly the data path that has been just connected with the PDN, server's PDN, and the PCRF is also connected with RX plus interface with directly to the PDN. So coming up to the next slide, before that it's also written that EUTRAN and EPC. I have just mentioned that EUTRAN is called with a combination of E node B's with your LTE. While coming to the core part, evolved packet core, you will find the S gateway and P gateway are just coming up together and make the Psi gateway. So this comes under the evolved packet core. Now coming to one by one detailing of each and every unit. LTE is connected with E node B, as I have highlighted E node B because we are just going for the details of E node B now. So E node B is connected to E node B by X2 interface, E node B is connected to MME by S1 MME, and E node B is connected to S gateway by S1 user plane. So coming to the functionalities now, functions for radio resource management, radio bearer control, radio admission control, connection mobility control, dynamic allocations of resources to UEs in both uplink and downlink scheduling, IP header compression and encryption of user data stream, routing of user plane data towards serving gateway, that is S gateway, scheduling and transmission of paging messages originated from MME and have been just forwarded to the LTE by using the LTE interface, scheduling and retransmission of broadcast information originated from the MME and O&M, measurement and measurement reporting configurations for mobility and scheduling, scheduling and transmission of messages originated from the MME, performs all RRM functionality, radio resource management, and E node B can handle several cells. Now E node B is connected to S1 MME, as I have highlighted, MME mobility management entity. So let's have a look that MME is connected to how many units, and after that we will go for the detailing. MME is connected to MME by S10 and with HSS by S6A, with SGW through S11. So pure signal entity inside EPC, evolved packet core, inter CN node signaling for mobility between 3GPP access networks, handles attach and detach to the SI system, as well as tracking area update, PDN gateway and serving gateway selection, handles roaming, bearer management functionality including dedicated bearer establishment. MMEs can be interconnected via the S10 interface. It generates and allocates temporary IDs for UE, AS security control, tracking area list management for UE in idle as well as in active mode, supports for message transmission, coming to serving gateway SGW, starting from the E node B, its S1U is connected with the S gateway, serving gateway, and serving gateway is connected with S5 and S8 interfaces with the P gateway, and S11 interface between the MME and S gateway. So as I have highlighted, serving gateway. So coming to the details now, manages the user data path within EPC, connects by S1 interface towards E node B, packet routing and forwarding, connects the PGW with S5/S8 interface. The serving gateway is controlled by one or more MMEs by S11 interface. Transport level packet marking in the uplink and downlink. EUTRAN idle mode downlink packet buffering and initiation of network triggered service request procedure. Mobility anchoring for inter 3GPP mobility. The local mobility anchor point for inter E node B handover. UL and DL charging per UE, PDN and QCI. Bearer and QCI granularly for inter-operator charging. Okay, coming to PDN gateway now. S gateway is connected with P gateway. P gateway is connected with PCRF also using the interface S7, and it's connected with the server PDN also. So coming to the functionalities now, provides the connection between EPC and number of external data networks, UEIP address allocation, quality of service coordination between the EPS PDN and EPC, connected by S7 to PCRF, transport level packet marking in the uplink and the downlink, UEIP address allocation. Okay, this point has been just repeated up there. Okay, fine. Per user based packet filtering, ULNDL service level charging and rate enforcement, ULNDL service level gating control, DL rate enforcement based on APN AMBR, that is access point name and maximum bit per rate, lawful interception, DHCP functions. Coming to PCRF now, policy charging, policy control and charging rule functionality. But basically it's the full form is based on policy charging rule functionality. Coming to the structure now, P gateway is connected with PCRF with S7 interface and RX plus with the external PDN, that is the server PDN. So coming to the functionality of PCRF now, quality of service coordination between the external PDN and EPC. PCRF is connected by RX plus interface to the external data network PDN. Check and modify the quality of service associated with the SI bearer setup for SI, or to request the setup for SI bearer from the PDN. Enforce minimum QoS quality of service parameters for packet based on their quality of service parameters. Charging policy determines how packet should be accounted. Coming to the HSS now, HSS is connected with the S6 interface with MME. Similar to HLR in the 2G and 3G network, contains all the information of all the subscribers registered at the particular HSS. With LTE/EPS, the HSS will get additionally data per subscriber for mobility and service handling. The HSS can be accessed by the MME via S6A interface. It has also been used for the authentication of the subscriber with MME by using the number of keys it's having. Now you can see there are multiple eNode Bs and I am having a single S gateway and P gateway. But now I am having two S gateways with a single MME. So this slide is regarding the flex, S1 flex. Let me just tell you how they are just connected. In a S1 flex, it shows the flexibility that a single unit has been just subdivided or just connected with the multiple units, maybe at the lower level as well as the higher level. So as you can see, eNode B1 and eNode B2 are just connected with a single MME as well as with the S gateway 1, the upper one. Let me just take the marker to just, okay, this one is eNode B1, eNode B2. They are just connected with this MME and just connected with S gateway, this S gateway. But taking that as an example of eNode B2, it's connected with two S gateway at a particular time. It's connected with two S gateways instead of one. Coming to the third eNode B now, it's connected with two MME at a single amount of time. It's connected with two MME. That means a single eNode B can be just connected with two S gateways as well as with two MMEs also. Similar is the case with the S gateway. two S gateways are connected with a PDN, as well as it is also possible that two S gateways are just connected with the separated P gateways also. Coming to the detailing now, E node B1, single S1 MME and single S1 user plane. E node B2, single S1 MME and multiple S1U, that is S1 flex U. E node B3, multiple S1 MME, that means S1 flex MME and single S1U. So the flex means the multiple. So multiple S1 MME is S1 flex MME, multiple S1 user plane is S1 user plane. Now coming to the main diagram, in which we'll have a look how all the technologies 2G, 3G and 4G are connected with each other. As you can have a look, starting from the E node B. E node B is connected with MME and S gateway, and S gateway is connected with P gateway, PCRF now, and the PDN. This is the same slide that we have just covered in the starting. Now starting with LTE, going to the 3G, it's node B, RNC, SGSN, GGSN, and again connected to P gateway. So it's having the calling, it's having the CS and PS domains different, but in LTE we are having totally PS domain. Coming to the 2G now, in 2G we are having BTS, BSC, MSC, and PSTN voice network. But this is the main unit, that RNC and S gateway are connected with S12 interface, while MME and SGSN are connected with S3 interface. These all are control planes. MME and HSS are connected with S6A interface, and HSS is connected with SGSN also with S6D interface. So these are the interfaces that are that all are just connected with each other. Now coming to the frame structure, LTE FDD frame structure, as we can see, is the frame 1 having the duration of 10 ms, is being just subdivided into subframes of 1 ms. That means there will be 10 subframes in a single frame. Coming to the slots now, in a single subframe you will find 2 slots. That means there will be 20 slots in a single frame, and a single slot is just subdivided into symbols, 7 symbols in case of normal, as well as in case of the extended it will be just divided into 6 symbols. So when I'll just go for the duration of a single slot, it's 0.5 ms only. So 7 symbols are just having the duration of 0.5 ms, and when I just multiply it by 20, I'll get the duration of 10 ms, that is 1 frame. Coming to the TDD frame structure now, is the same frame structure, but it's having the DWPTS, that is downlink pilot time slots, and uplink pilot time slots. And DWPTS facilitates downlink synchronization, and guard period is to just avoid the interference between the uplink and downlink, and provides the transceiver adequate time to switch from transmit function to receive function and vice versa. Uplink pilot time slot facilitates uplink synchronization. Coming to the special subframe, in this there are multiple types of subframes that are being just used in case of LTE. So coming to DWPTS first, shortened DL subframe, and for referencing the and control information, may carry user data, contains PSS, and in uplink pilot time slot, mainly used for RACH and SRS transmission. And about the guard period, switching point between DL and UL transmission, compensates for the delay between the transmission directions when switching. Its length determines the maximum supportable cell size, and in the table you can have a look. It's UL and DL configurations. There are multiple configurations, 7 types, and having the duration also. As you can see, it's having 5 written there. That means the duration of 5 subframes only is just keep on repeating DSUUU, and here also you can have a look DSUUU. That means it's keep on repeating after every 5 ms. And when we just look at the 10 ms duration, you can have a look that this whole 10 ms will work as a unique one. It do not keeps on repeating DSUUU, and the rest of them are just used for downlink. Same is the case of type 4 DSUU, and rest of them are just for downlink. So S is the special subframe that comes after downlink and before uplink always, because as you can have a look, downlink pilots and uplink pilots, then only you will have the guard period, not after the uplink to downlink. So these are the different formats. That's it from my side for today, and let me know if you are having any query or any suggestions. Thanks for watching the video. Thank you.